Alright, this is going to be day 29 notes for AP Stats. We're starting chapter 11. And what we'll be looking at in these chapters is probability. And the deal is we're actually not necessarily going to know probabilities in all cases, and so we need to be able to do something called simulations. So the first thing that we talk about is how to conduct a good simulation so that we can estimate the probability of something happening. So the first thing, we're just going to take a look at a situation, a problem here, and you don't have spinners, but I'll show you a little thing on your calculator that will allow you to have a spinner. I'll give you a couple of different ways to do this. So suppose that we have a cereal company. This is right in your notes, at the very beginning of your notes. Suppose that we have a cereal company that places 1 of 4 toys in every box of cereal. So furthermore, the company claims that each toy is produced in the same quantity, so each of the toys is equally likely to show up in a randomly chosen box. I want all 4 toys, but it takes me 15 boxes to find each of the 4. Is this evidence that the toys are not uniformly distributed? Estimate the probability that it takes 15 or more boxes to get all 4 toys, assuming that the company is telling the truth. So we want to estimate the probability that it takes 15 or more boxes to get all 4 toys, and we're assuming that the company is telling the truth. So the first thing we need to look at is, what question are we actually trying to answer? We are trying to answer what is the probability that it takes 15 or more boxes to get all 4 toys. Was that unreasonable? And if they're all equally likely, wouldn't you assume that if you just bought 4 boxes, you'd get 1 of each? But that wasn't the case here. It took us 15 boxes to get all 4 toys. So the way we'd write this as a problem is, what is P, the probability that it takes 15 or more boxes, that X is greater than or equal to 15 to get all 4 toys. Okay, so our X variable are what we're looking for. This is basically our response variable. So we're looking for this probability, and this isn't a big deal right now. What we want to do is figure out what is the probability. Okay, so we don't know what kind of cereal this is. We can't go out and buy the kind of cereal. So what we're going to do is we're going to conduct a simulation. So there are 7 steps for a good simulation. So we'll come back to this problem actually, and we'll actually do the simulation, but there are 7 steps for a simulation, which you will need to conduct every time. And so they're slightly modified from the book. So if you read the book, they give a slightly different number of steps. They are just fine as well. So number 1, identify the component to be repeated. What are we repeating? So in this case, for our problem, we'll write the 7 steps for our problem as we go. So the component to be repeated, what are we doing? We are opening a box of cereal and identifying a toy. So we're opening a box of cereal and we're identifying a toy. That's what we are repeating in our situation. Okay, so what you'd be writing for an answer, step 1, the component to be repeated is opening a box of cereal and identifying a toy. Step 2, or the second thing, explain how you will model the outcomes. So this is where you really have to think. We're assuming that each of the toys is equally likely. So the chances of getting any one of the 4 toys in the box should be 25%. So we would need to, there's lots of different ways. We could use a random number table and choose 2 or 3 digit numbers and use the numbers 0 or 1 to 100 or 0 to 99, with 0 through 24 representing the first toy, and 25 through 49 representing the second toy, and 50 through 74 representing the third, and 75 through 99 representing the fourth. So basically taking 100 and breaking it up into the 4 quarters, 25%. And we could then just use a random number generator, do random integer on our calculator, and model it that way. What we also have on our calculator is a spinner. Since I'm going to have a spinner with 4 equally likely outcomes, so we could use a random number table. We can use numbers 0 through 99. 0 to 24 represents toy 1. 25 to 49 represents toy 2. 50 to 74 represents toy 3. And 75 to 99 represents toy 4. And you could look those up on like a random digit table. Remember, a random digit table might look something like this table of random digits here. So you would pick pairs. Like that would be 57 would then be toy 3. 87 would be toy 4. 83 would be toy 4. 5 would be toy 1. That would be toy 3 again. Toy 3. Toy 4, toy 4, and toy 1. See, we still haven't gotten a toy 2. That would be toy 4, toy 4, 4, 1, 4. That would be 3. That would be 3. That would be 3, 4, 4. Oh, finally we get a toy 2. So then we'd have to go back, and each of these was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. It took us 21 tries just to get all 4 toys. Now that's an example of how I could simulate this. Okay, what we're actually going to do, what you can do and practice on your calculator, this is one example of how you can simulate it. And the key here was that they were equally likely. That's why I had to have these 25 sets of numbers. What we're going to use is we're going to use a spinner. And this spinner is numbered in this fashion. And we spin the spinner, and we're going to spin it until it lands on all 4 sections. So we're going to spin our spinner until it lands in all 4 sections. That's what we're going to do here. So this is going to represent opening a box and identifying the toy. Alright, so step 3, explain how you will simulate the trial, or run is sometimes what they call it, the sequence of events. A trial is the sequence of events that we are pretending will take place. So we've actually already kind of done it once here, but we're going to do it with the spinner now. Now your calculator actually has a spinner on it, so okay, so on your calculator, if you hit this apps button, APPS, and you go down, 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 there, prob sim. Hit enter and hit any key, and we want to do number 4, spin the spinner. And we're just going to do one trial at a time, really nice and boring. But what I'm going to do is I'm going to spin it. I'm just going to hit this spin button, and it's going to spin the spinner for me. So what I'm doing is I'm just writing down a spin. So I got a 2. Okay, now I'm just going to spin it again. Spin it again. And this time it lands on 3, and I'm just going to spin it again. And I need to write down every one of them in order. And I get a 2 again, and I'm going to spin it. This +1 will spin it every time. And so now I got a 3 again. Keep spinning it. Just hitting that +1 button is going to spin. And I keep getting that darn 3 or 2. Let's get a little variety in here. Nope, I got another 2. And I have to keep doing this spinning until I get all 4 sections landed on. There we go. So now, this is me conducting a trial. I've spun my spinner. So what I did, an example of it, and actually I'm kind of combining a couple steps. So I will spin a spinner, and I draw a picture of the spinner so I don't have to describe 1, 2, 3, 4 until I land on all 4 sections. Then count the number of spins I needed to get all 4 toys. So I'm kind of combining some steps here. So technically we go back to this step. We're going to spin our spinner until it lands on all 4 sections. So explain how I'm going to simulate the trial. So we already know we're doing that. I will spin the spinner until I land on all 4 sections. Then I will count the number of spins I need to get all 4 toys. And this is an example, okay? And this will actually be a later. So we'll come back to this. We'll need this again. Alright, so now we're on step 4 for our how to conduct a good simulation. We want to state clearly the response variable. And this is the same as in experimentation. The response variable is what we're looking for. So in our case, the response variable is the number of spins needed to land in each of the 4 regions. So that's X. That was the X that we wrote at the very beginning, right up here. The probability that it takes us more than 15 boxes to get all of, in other words, and what this really means is number of boxes of cereal to land in all, or to get all 4 toys. That's really what it means. Alright, 5, give an example. Of one trial. So we actually already did that earlier when we did this thing up here, and we wrote down, so one trial, we're spinning the spinner, these are my spins, and if you've written all this other stuff down, this is one trial right here. We count 1, 2, 3, 4, 5, 6, 7, 8. We had to open 8 boxes of cereal to get all 4 toys. Okay, step 6, analyze the results. This is usually done with a graph or table. Graph or table, dot plot type thing. And we'll do that in just a little bit here. And 7, state your conclusion. Alright, on the next video we'll actually finish up this example, do a few more trials to get a probability.